Okay, based on what you looked at in the Desmos activity, we're going to practice a little bit with even and odd functions as trig functions and just clear up a few things. So your definition for an even function was that if you plug in x and you plug in negative x, you get the same output. So if I plugged in 3 or negative 3, so for example, f of negative 3 would be exactly the same as f of 3. Whereas an odd function would say if I plugged in x or negative x, I'm going to get a different output. So if I plug in negative 3, I'm going to get the opposite of the output I would have gotten if I plugged in just 3. So those are our two options here. In your Desmos activity, hopefully you were able to figure out that the even function is just cosine. Now, secant will also be even because it is directly related to cosine. It's just the reciprocal. So it's still going to have that same even behavior. Our odd functions are going to be sine and tangent, and both of their reciprocals as well. So when we look at an example where I give you something about a particular trig function, so let's say I give you that sine of some angle t is radical 7 over 5. And then I ask you to figure out, okay, what is the sine of negative t and what's the cosecant of negative t? So the first thing we have to decide is whether this function is going to be even or odd. Because it is sine, if you look below, that means that it's an odd function. Okay, so that means that f of negative x is going to be equal to the opposite of just f of x. So what I'm given here is basically sine of t, okay? So if I change that to sine of negative t, what that means is I'm going to take whatever the output was here and just change the sign of it. So it's positive here, which means that if I take the input and make it negative, I'm going to take the output and change whether it's positive or negative as well. So this just becomes negative radical 7 over 5. That's it. Because sine is an odd function, when our inputs are opposites, our outputs will also be opposites. Now, there's a difference between opposite and reciprocal. So the relationship between sine and cosecant is that these are reciprocals of each other, right? So these are reciprocals, which means that whatever sine is, cosecant is just going to be the reciprocal of that. We're going to flip the fraction. So we're going to flip the fraction and make it negative 5 over radical 7. But once again, as we've seen in some previous examples, we want to rationalize the denominator. So really, we end up with negative 5 radical 7 over 7. Okay, let's try a couple more. So this time, we're going to look at the cosine of w. Now, the cosine is an even function. All right, so the cosine is an even function. I'm just going to highlight these so they correspond. So our even functions say that no matter what our input is, the outputs remain the same. Okay, so f of 3 and f of negative 3 are going to be the same. So if I have cosine of w, and then I'm asking you to find cosine of negative w, those are going to have the same exact output. So the output of cosine of w is radical 41 over 8. That's what the output for cosine of negative w will be as well. All right, and then we're going to look at the fact that cosine and secant are reciprocals of each other. And this time we're asked to find the the secant of negative w. So we're doing the reciprocal of the cosine of negative w. So remember, reciprocal just means flip. So we're going to do 8 over the square root of 41. And then again, we're going to rationalize our denominator. So multiply by the square root of 41 over the square root of 41. And we get 8 square root of 41 over 41. And that is the secant of negative w. Okay, last but not least, let's talk about tangent. So tangent is an odd function. All right, so when I look down here, I see it's in one of these 4 functions that's odd, and that's just like the sine function. So whether we take, if we take the the input is the opposite of our original input, the output is also going to be the opposite of our original output. So the tangent of negative theta, so this is an odd function again, okay? I guess I could write this as even over here. The tangent of negative theta, if we change that negative theta to positive theta, we have now changed the input to be the opposite. Therefore, our output will also be the opposite. So my output for the tangent of theta is going to be the opposite of what we have above. So that means negative radical 3 over 3. And then once again, I look at the fact that these are reciprocals. So that just means I flip them. So I'm going to flip negative radical 3 over 3 to get negative 3 over radical 3. And then once again, I rationalize. So let me multiply by the square root of 3 over the square root of 3. Now we have to be careful with this one because look what we get. We get negative 3 radical 3 over 3. There's a giant 1 there. Okay, so what we actually end up with is negative radical 3 as the cotangent of theta. So really the hardest part about these problems is going to be rationalizing the denominator. Okay, now go back into your Desmos and try to finish up the activity.